I welcome you all for my programming in Java introduction class. Let us get into that. Yes, Java is created by James Gosling from Sun Microsystems in the year 1991. And the first public version was available, that is Java 1 was available in the year 1995. After that, in the year 2010, Sun Microsystems was acquired by the Oracle Corporation. Over the time, many versions have been evolved. Usually, Java version will be released twice in a year. Therefore, the latest version of Java is JDK 24, which was released on March 2025. And most probably, Java has numerous applications. Let us see some of them. Java applications are desktop GUI applications, mobile applications, enterprise applications, scientific applications, web-based applications, embedded systems applications, distributed applications, gaming applications, so on. While seeing desktop GUI applications, the applications such as Acrobat Reader, Media Player, antiviruses, etc., like these applications, Java is used to build the desktop applications. And what are mobile applications? Most of the Android mobiles applications have been built using the programming language Java. Okay. Like the applications, photo gallery apps, calendar apps, Netflix, and so on. Then comes the enterprise application. What is an enterprise application? It's a large software system, particularly meant for an organization. It may be a school, college, bank, government sector, etc. Okay. Next comes the scientific applications. Okay, scientific applications will affect the real world activities. For example, a research tool MATLAB can be is used for research purpose and it was built using the Java programming language. Many of the research applications like medical science, space, aeronautics, etc., have been built using Java programming language. Okay. Then in web-based application, what is a web-based application? It's a client-server program that is delivered on the internet through a browser interface. Web-based applications, for example, IRCTC, online form, shopping carts, Gmail, etc. Like these web-based applications can be developed using Java programming language. And then what is an embedded system? Embedded system is known as an integrated system. That is a combination of many tiny computing units that is assembled together to perform dedicated functions for a large system. Small computing units assembled together to a larger system. For example, phone, TV device, washing machine, etc. Everything have the embedded system into it. The 3 billion mobile phones and 125 million TV devices are using Java currently. See how Java programming is used in the real world application. Okay. Then comes the distributed applications. What is a distributed application? Is an application or a software that executes or runs on multiple computers within a network. Example, it may be internet, email, etc. And telecommunication network, telephone networks, and cellular networks. And real-time process control. What's a real-time process? Is real-time aircraft control system. Yes, it's a real-time. To be done really, also live action on e-banking, airline reservation, railway reservation, many real-time process control are there. For those applications, these comes under those application comes under distributed application, and for those applications, Java can be used to build those applications. And what are gaming applications? Yes. And if we go for Android phone, we have Android games. Most of the games. Majority of the games were built using Java. Okay. Now we are moving to the next topic called features. What are the buzzwords or keywords or speciality or characters of Java? We are going to see. What are the characteristics? It's a simple It is object oriented, it is secure, it is platform independent, it is robust, it is portable, it is architecture neutral, it is dynamic, it is interpreted, high performance, multi threaded, and distributed. We are going to see one by one in a simple way. Okay, let's get into that. Yeah. How it is simple? Why do we say Java is simple? Yes, because the syntax is mostly based on the C language, and OOPS concept, object-oriented programming concept, is based on C++. So easier for the programmer to learn after C and C++. Then what is the next point? Why it is simple? Yes, many confusing concepts like explicit pointers and operating overloading have been removed from C++. And no, and then third point is the automatic garbage collection. What is the meaning of automatic garbage collection? The unused memory space is automatically collected by the programming language itself. In C++ and C language, we claim as a programmer, we write coding to reclaim the unused memory space. Here, Java does it automatically. This is called as automatic garbage collection. Therefore, for these reasons, Java is always simple. And what is object oriented? Yes, object oriented programming is a methodology of programming that makes software development very simple and maintenance. Okay, it does the simplify the software development and maintenance. What are the concepts that comes under OOPS are objects, class, inheritance, polymorphism, abstraction, and encapsulation. Let's see one by one. Okay. Okay, anyway, we'll be seeing it later. Now we can continue with the features of Java. Yes. This platform independent. Before that, what is a platform in technically speaking? Yes, it's a hardware or the software environment in which a program runs. It's an operating system. It may be a environment for programming language to run. It comes under the, and or maybe a hardware device. Therefore, it's a platform is for the hardware or a software environment. Okay. Java can run on multiple platforms. For example, it can run on Windows, Linux, Solaris, Macintosh OS, etc. Yes. See here, see in this example, here, if we compile a Java program, we get a code. If we compile a Java code, we get a class file. The source file will be compiled to a converted to a class file. If we take that class file and we can run on any machine, we can run on Windows machine. We can take the same class file and run on Windows or Linux or Mac OS machine. That class file contains a byte code, which is an intermediate code, which is compatible for all the platforms. Okay, therefore, Java code is compiled by the compiler and is converted into a bytecode. And bytecode is a platform independent code. Because of bytecode only, Java is called as platform independent because it can run on many platforms. For example, if we take a C++ coding, we compile it, we won't get the intermediate code, we get the object code, machine code. But we cannot take that object code. We cannot give the guarantee that C++ converted to object code runs on all the platforms. But Java code runs on all the platforms because the intermediate code called bytecode is platform independent. So that we can tell that is Java is follows Aura. What is that Aura? Write once and run anywhere. We can write Java once and we can run on any platform. That is a main advantage or main feature of Java. That is platform independent. Okay. Why Java is secured? Yes, Java is secured because of 2 points concept. That's it has no explicit pointer. What is a pointer? Pointer is refers to the address of a variable. If we know the address of a variable, we can steal the data or we can modify the data. but there is no possibility for this. And what is second point? Java program run inside the virtual machine sandbox. That means that here in this diagram, if we take a C++ application, it takes the runtime environment for a particular operating system. For example, if I run in the Windows operating system, it takes that Windows environment. If I run in the Linux OS, it takes the Linux environment, but Java takes its own runtime environment called JVM, Java Virtual Machine. The file is very secure. Okay. And what is robust? Java uses a strong memory management and it lacks a pointers concept and avoids security problem. And we know that automatic garbage collection, yes. And the last thing is exception handling and type checking mechanism. Yes, exception handling. How to handle the exceptions at runtime. That is the main thing. If you have created an application, but it's not handling the exceptions, then the application will be a failure. You should handle all type of exceptions at runtime. That makes an application successful. Because we had an exception at runtime, what happens? The application will terminate abnormally. We should handle that, and we should not abruptly terminate the application. The application should execute. The normal flow should be there. By handling the exception, we can do that. Okay. Then what is interpreter? After compilation, the Java program is converted into bytecode format. Yes, we know that it's an intermediate code and it is responsible for platform independent. We know that. And that bytecode can be interpreted on any system that provides a JVM. That is called interpreter. Yes, if there is JVM in a machine, then we can interpret that. Bytecode can be interpreted. Okay. By using the JIT compiler. Right. Okay. Then what is architecture neutral? There is no implementation dependent features. Yes. It does not depend to a particular architecture. For example, to be more precise, the size of the primitive types is fixed in Java. It does not depends upon primitive types means what integer, character, float, string like that. They are fixed. But in, for example, in C language, the size of the integer data type is 2 bytes in 32-bit machine and 4 bytes in 64-bit machine. But in Java, the integer data types always occupies only 4 bytes because the programming language does not depends upon a system architecture. Therefore, it is architecture neutral. Okay. Then what is dynamic? What is dynamic? Because it can verify and resolve objects at runtime. Yes, what is the meaning of verify and resolve objects at runtime? Yes. For example, if I want to, at runtime, we can get the information through which method to be called will be known only at runtime. And it will be implemented using the applet concept. What is an applet? It's a small fragment of code that is dynamically updated on a running system. And what is portable? Portable means that we can carry the Java bytecode. We can carry the Java bytecode to any platform. It means that you can carry that. Therefore, it is platform. It is portable. Okay, yes, we can carry the Java bytecode to any platform so that that code can run anywhere. Okay, it's very portable, easier to handle. Yes. Then what is high performance? Was designed to easily bytecode was designed to easily translate directly into a machine code using the just-in-time compiler. Yes. Okay. First Java source code is converted to bytecode and then it should be converted to the machine code. It is done by JIT compiler. And therefore, it has the high performance cross platform. Yes, high performance, yes, it's converted easily using the just-in-time compiler quickly. And that machine code can work in any platform. Therefore, it is high performance cross platform. Then what is distributed? Why do we say distributed? Yes, we can create distributed applications in Java. That is RMI, remote method invocation, and extended Java beans are used for creating distributed applications. Yes, what is a distributed application? What is RMI? We can access the files by calling the methods from any machine on the internet using RMI. Using RMI, we can access data or files from any machine. What is RMI? It's remote method. It's remotely calling a method to access a file on any machine through internet. Okay. And at last, the last feature we are going to see what is multi-threaded. Before that, what is a thread? Thread is a separate program that is executing concurrently. I can give a simple example. You take a game, a simple game. A game consists of audio, video, timer, score. We can take these four things, very basic things: audio, video, timer, and score. Audio is a one task, video is a one task, and then timer, and then score. All the four things should be executed simultaneously at the same time when we start the program, start the game, and all the four threads, each and have, I'm going to have it as a thread. Audio thread, video thread, score thread, timer thread, all the four threads should be terminated whenever I stop the game. Can take example like that. Therefore, it's a thread is like a separate program executing concurrently. We can write Java programs that deal with many tasks at once by defining multiple threads. Yeah, can do many tasks at once by defining multiple threads. In real-time example, I can mail from my system. I can give print requests. I can hear audio, music. I can do multiple tasks. And each and every task is considered as a thread and it is done simultaneously. Why do we go for multi-threading is that in a same memory is used for all the threads. The threads are sharing the memory. Whenever one thread is sleeping or suspended execution, other thread will use that. But suspended and resuming will be done in nanoseconds so that the human cannot identify that. We think it is all the threads are done working simultaneously, but the threads are not working simultaneously because the differences of suspending the thread and execution of thread will be in the nanoseconds. So that the same memory can be used for all the threads. A single processor can be used for all the threads. Its processor at a time can process only one thread, but by swapping between threads, it can do. The swapping duration is very minimal, nanoseconds, which a human cannot identify that. That's the thing. Okay. Therefore, the main advantage of multi-threading is that it does not occupy memory for each thread. It has a common memory area. And threads are more important for multimedia, graphics, web applications, game, everything we use a thread concept. Okay. Then moving on to the next topic, object-oriented programming concepts. Yes, what are they? It's a very simple thing. So, object-oriented programming makes us to program simply and maintain it simply. Okay, what are the concepts we can see that? Okay, develop and maintenance. That's a basic thing. Okay, what are the concept that comes under object-oriented programming? Object, class, inheritance, polymorphism, abstraction, and encapsulation. Okay. What is an object? As an object is a real-time entity. A pen, a chair, a student, a person, a train, a bus, everything. It's an entity that has state and behavior. It may be a place, person, or a thing. Okay. Here, entity that has state and behavior means what? Variables and methods. Okay, variables are called states. That is name, age, sex. If a person is going to be an object, what are the properties or state of a person? Name, age, sex, qualification, like that. And what are the behaviors? Reading, writing, drawing, or the functions of the person, particular student. Okay. For example of objects are what? Chair, pen, table, keyboard, bike, etc. It can be physical or logical. Yes. May not be physical. It can be a logical. Ticket is logical. Software number is logical. Okay. Pen, pencil, or physical. Okay. An object can be defined as an instance of a class. An object contains an address and takes up some memory space. Okay. An object contains an address and takes up some memory space. For example, a dog is an object. And what are the states of a dog? Color, name, breed, etc. And what are the methods of the dog or behaviors of the dog? Wagging the tail, barking, eating, etc. Okay. Now comes class. For example, collection of similar objects belong to a class. For example, mango, apple, banana, papaya, all are the objects of the class fruit. Yes, therefore, collection of similar objects is called class. Okay, it's a logical entity. And a class can also be defined as a blueprint from which we create an individual object. Yes. Suppose I create class called student. I'm creating five students, S1, S2, S3, S4, and S5. Therefore, there'll be some blueprint for that. What are the attributes the student is going to have? SI, student ID, student name, student age. What are the methods or behaviors they are going to build for the students? Calculate the result, print the result, like that. What is inheritance? The basic advantage of object-oriented programming is reusability. Suppose you have written coding, for example, the version, for what is reusability? No need to write the coding from the scratch. You can extend that code. We can reuse it and we can modify to our customize it. Okay. Yes, for example, we have the versions in a software. Okay, the newer version will not be written from the scratch. It will inherit some parts of the older version, and then some things will be newer. Therefore, inheriting the basic version or previous version, and then additionally, some new concepts have been added to the newer version. That is reusing it, reusing the older version, reusing the coding. Suppose I'm having 10,000 lines of coding. It's possible for me to take 6,000 lines of coding from the previous and I can change only the 4,000 lines or like that. Okay. And what is polymorphism? Yes. If one task is performed in different ways, it is known as polymorphism. Here, see here, what is the task here? See in the example, the task is speak. Yeah. Here we speak, the way of speaking is different. Different for dog, different for cat, different for duck, etc. For the common thing, commonality here is speak. But different living beings speak differently. That is called polymorphism. One task is performed in different ways. It is known as polymorphism. Okay. Yes. What is abstraction? In Java, we use method overloading and method overriding to achieve polymorphism. Okay. Now, what is abstraction? Hiding internal details and showing functionality is known as abstraction. Yes. But what is the example we are going to see? A phone call. We don't know the internal processing of the phone call. Just we attend the call and then we talk and then we leave the call. Okay, but we don't know what are the internal processing. This is called hiding the internal details and showing the functionality alone. That is called abstraction. In Java, we use abstract class and interface to achieve abstraction. Right? What is encapsulation? Binding or wrapping code and data together into a single unit are known as encapsulation. Yes, what is a capsule? It's a combination of many medicine as a whole. Therefore, binding up of code and data together, coding and data together into a single unit. The best example is a class itself. We are going to create a class, definitely we'll having a code and data for that particular class. It will be inside the class, we'll be binding inside the class. That's for a good example for encapsulation itself is a Java class. Okay. At last, we are going to see Simple example for class. Yes, I have, here the class name is student. And how many objects? Yes, suppose I have 40 students in my class. I can create 40 objects of the class student. So here, the student is the class name. S1, S2 are the objects I have created. And um, what are the variables here? SID, student ID, student name, student age. It goes on. I can have many student class, student marks like that. I can are variables. Here S1, S2 are objects. And what are behaviors or functions or methods? Behaviors are calculate attendance, result. I can do anything, any behavior, any method I want, I can create. I want to create calculate the attendance. Attendance will be calculated for all the 40 students in my class. And result processing. Result processing will be done for all the 40 students, but the results will be different. The marks will be different. Attendance will be different. Therefore, each object has its own student ID, student name, student age values. The output of each object, S1 and S2 for calculate attendance and result processing will be unique. Yes, it will be different. It depends upon the attendance scored by S1 and depends upon the marks scored by S1. Attendance and result processing will be varying. Right. Okay. That's it. Thank you.